Hey folks, welcome back. It's Mark Noldy, Planet Numeracy, and following up today with a video I did previously with some very basic trigonometric equations. These ones are going to be a little bit more complex, but nothing, surely they can get harder, but this is about the extent of what you would probably see on a final exam in pre-calculus. All right, so first let's start with uh, uh, have a double angle formula here. Um, you can look on your sheets usually. I think most teachers will give you a sheet of identities. Um, if you're not certain where this actually comes from, uh, be an angle addition formula. So sine x plus x, sine of x plus x. So we use our double angle, which be the sine of the first angle times the cosine of the second angle, plus the cosine of the first angle times the sine of the second angle. So what you have here is you have sine x cosine x and sine x cosine x. So you have two of those, two sine x cosine x. So I don't know, some students maybe don't remember where that came from, but in any event, we're going to use it right here to replace sine of 2x. All right, and then I just have minus cosine x, that's still coming along, and it's set equal to 0. All right, this sets up a nice situation where we can factor cosine of x from this expression. So, or some students call it undistribute. We're undistributing. So if I had cosine x times 2 sine x equals this, and cosine of x times minus 1 is minus cosine x. So what we have is a multiplication here. So if this times that equals 0, either this is 0 or that is 0, right? Zero product property. So I'm going to say cosine of x equals 0, or 2 sine of x minus 1 equals 0. So cosine of x equals 0. So cosine equals, I didn't give us a domain. Say the domain is 0 to 2 pi, which is what a lot of these usually are. So 0 to 2 pi, and so x, where is cosine equal to 0? That would be at pi halves, or 90 degrees. This also you might see as a 0 to 360 degrees, but they essentially mean the same thing. So pi halves, and the cosine is 0 also at 3 pi over 2. And then every pi thereafter. So if I kept adding 2k pi, 2k pi, 2k pi to this, 2k pi, 2k pi to this, I could generate an infinite number of answers. But we're just going to go with the ones that are in our typical range here. All right, second piece of this equation is, let's say, 2 sine of x. Add the 1 on both sides. Divide each side by 2. So sine is 1/2. So what angle has a sine of a half? Well, that would be 30 degrees, or pi 6. And that would be also what? Think of where is the sign positive? Sign would be positive here at 30 degrees, which is also pi 6. I'll put them both in there. So this is a 1, 2, root 3 triangle. So, but the sign is also positive over here. So let's make a reference angle of pi 6, or 30 degrees. that would make this angle, let's see, we use a green. This angle is the angle that I'm looking for. So instead of 6/6, I would say it's 5 pi 6. So 5 pi over 6. So there you have it. 4 different solutions that make this equation true. This original equation. So remember, a solution in trigonometry is the same as a solution in pre-algebra and algebra. It means if I put these numbers in place of if I put these values in place of the x in the equation, it's going to give us a true statement. And that is, well, there's the first one. I have another one on the next page. Here we go. Ooh, this one requires factoring. So imagine that this is, if this said 2, oops, let me get some ink here. If this said 2 x squared minus 7x plus 3, could I factor that? Let's say it's equal to 0. I could factor that. Right? If it factors, I should say, it would look something like this. And oh yeah, this factors. So -3 and -1. So my outers, 2x and minus 3, give me minus 6x and a minus 1x. So minus 6 and minus 1 is minus 7. And last times last, -1 times -3 is the positive 3. So just imagine that you let x be equal to the sine of x, or you let the sine of x be equal to x. So if you were to think of it this way, it would be a little bit easier to factor this one. So this would be sine x and sine x. So 2 sine x times sine x is 2 sine squared x. Okay? All right. Oops, forgot my other parenthesis here. And same as before, we're going to have a minus 3, same as from over here, minus 3 and a minus 1. So FOIL this back out and you'll see that first, we already looked at first times first is 2 sine squared x. The outers, -6 sine x. The inners, -1 sine x. So those add up for -7 sine x. And -1 times -3 is positive. -1 times -3 is positive 3. So same as before, if this times that equals 0, either this is 0 or that is 0. So let's set that up. 2 sine x minus 1 equals 0, or sine of x minus 3 equals 0. All right, I'm going to do the one over here on this side first because it's kind of easy to do. It is, when I add 3 on both sides, I get the sine of x is equal to 3. Are there any angles whose sine ratio is 3? No. They're all between 0, and the theta has to be between 0 and, well, not 0, -1, and +1. There are no sines, there are no angles who have a sine of 3. You could have like a tangent of 3, but you'd never have a sine or a cosine, for that matter, of 3. So what do we say here? This is no solution. No solution to this piece. Or sometimes people just cross it out like that. That's fine too. Coming back over here, and I get 2 sine x equals 1. So we add 1 on each side, then divide each side by 2. And a lot of these problems, they're contrived, right, in your textbook. So they always work out nicely. So if I'm still looking at from 0 to 2 pi, you'd be saying that this x has got to be, we just did it on the previous slide, pi 6 and 5 pi 6. So those would be the two solutions in this domain. So far, so good. On to the next piece. Ooh, this is a good one. So how do I solve this? Well, I want to solve for the x, right? So I want to get this piece of the equation by itself. So I start by adding 3 on both sides of the equation. So 4 sine squared x equals 3. Then, let's see, sine squared of x is being multiplied by 4. So let's divide both sides by 4. So that gives us another equivalent equation. Sine of x squared equals 3/4. And the next thing we want to do is, let's see, have a square here. So I need to take the square root of both sides of this equation. So when I do that, I get the sine of x is equal to plus or minus square root of 3 over 2. Where's that 2 coming from? This 2 is the square root of 4. And remember, when you take the square root, it's plus or minus. All right, we're almost there. We have to find out what this angle is. What is x? And again, assuming we're on the 0 to 2 pi train here, let's see. Sine is positive in 2 places. Right? Sine's positive in quadrants 1 and 2, negative in quadrants 3 and 4. So I'm going to have 4 solutions here. So where is the sine equal to root 3 over 2? Well, if I think of my quadrant 1 angle. So root 3 over 2, and that would be a 1. So we know from special triangles that that's a 30, 60, 90 triangle. So that would be 60 degrees or pi thirds. All right, the other angle, or the other place that sine is positive, is over here. If I had a reference angle of 60, I'd have a negative 1, a positive root 3, and a 2. So that's why sine, if this is a 60-degree angle, would be root 3 over 2, the opposite over the hypotenuse. So, but what angle do I actually want? Let's see here. I want the angle, let me go green here. I want this angle. So this angle would be 60. This is 60. And then the rest of it would bring us up to 180. So this is pi thirds plus another pi thirds would be 2 pi thirds. So let's come back down here. We know we have now pi thirds and 2 pi thirds. But there's also 2 places where the sign is negative. So let's come over here and we'll do a new triangle here. So 60 degrees, new reference triangle. If this is 60, we have a 30. Here's a 1, here's a 2, and here's a negative root 3. So the sine of this angle, this is my reference angle, is negative root 3 over 2. That's why sine is negative down here in quadrant 4. So, but the angle I want again is this angle. So that would be, all the way around once would be, let's see, 3/3 brings us over to here. So this would bring us back over to 6 pi thirds. So this is 1 pi shy of that. this angle here. So we would say 5 pi over 3. And let's see, one more place. If I have a reference angle, 60 degrees here. Actually, let me clean this up a little bit for us. I'm going to be in quadrant 3. So here's quadrant 3. And my reference angle, 60 degrees. That makes this a 30. So here's -1, 2, negative root 3. So the sine of that, of this angle, is negative root 3 over 2. That's why sine's negative in quadrant 3. But what I really want to find is this angle here. So that would be 1, 2, 3, 4 thirds. So 4 pi thirds. So here are our 4 solutions. This is quadrant 1, quadrant 2. I guess I found quadrant 4 here first, and then quadrant 3. So it's very important to remember all students take calculus. Do we remember this? Say yes. All students take calculus. This means all of the trig functions are positive in quadrant 1. Sine is positive in quadrant 2, and cosecant, of course. Tangent is positive in quadrant 3, and so is cotangent. And this will be cosine, so secant also would be positive here in quadrant 4. And we say all students take calculus is how we remember that. It's our mnemonic device for the day. So hopefully you enjoyed this, got something out of it. If so, give it a thumbs up. And I'll be here again on the next one. In the comments below, leave if you're looking for a special type of problem that you need to see a solution for, feel free to put it down there, and I will work one up for you. All right, take care.